Getting a simple nav bar working in Flutter is pretty straightforward. Well, kind of. Chances are it won't be that simple. Let me explain. The most common approach to implementing the navigation bar in Flutter is to set up a single scaffold which contains the navigation bar widget. This makes it easy to switch nav screens. But try setting an app bar title, and you'll quickly find out it doesn't work so well, because these nav screens share a single scaffold. In this video, we'll cover both a simple implementation that uses a single scaffold and a flexible, well-designed multi-scaffold approach that uses a powerful state management technique called lifting state. With this technique, you'll be able to customize app bar titles and other scaffold level properties for each of your nav screens. We'll also spend a few minutes to walk through Nav Bar Customization. By the end of this video, you'll not only have a better understanding of the navigation bar widget, you'll also have a solution that you can easily apply to any future projects requiring a navigation bar. All right, let's jump in. We'll start from a new Flutter app and clear everything except for the import statement and the main function. Next, we'll define a stateful widget named MyApp. This is where our material app, scaffold, and navigation bar will exist. Since interacting with the navigation bar will require us to update the screen, this widget needs to be stateful instead of stateless. In our state class, the build method is currently returning a placeholder. We'll swap this out and return a material app. First, I'll hide the debug mode ribbon. Next, we'll set the home property, which is the initial widget that we'll see when the app loads. We'll create a scaffold and then set its body to a placeholder widget for now. Let's go ahead and restart to make sure this works. Okay, that looks good. The navigation bar we're creating will have three screens: Home, Search, and Settings. To keep things organized, we'll place them in a Screens folder. These screens will be quite simple and will consist of a stateless widget containing a centered text widget with some basic styling. To quickly create the skeleton for a stateless widget, I'm typing STLESS and choosing Flutter Stateless Widget from the IntelliSense menu. We'll do the same for search and settings, but since they're basically the same, I'll speed up this part of the video. Okay, so now that we have our three navigation screens defined, let's go back to main.dart and swap out the placeholder widget in the body property with one of the screens we just created. If I set the body to search screen and then perform a hot reload, we'll see the change appear in the simulator. Let's go ahead and import the remaining screens. For now, I'll set this to home screen. The navigation bar we're creating will essentially set the value of this body property to whatever screen has been selected. Now that we have a skeleton set up, let's get to the fun part and implement our nav bar. We can do this with the navigation bar widget. Flutter also has a bottom navigation bar widget, which is basically an older version. In this video, we're going with the newer version, which supports Material Design 3. To get the navigation bar widget up and running, we need to define three properties. First, we'll define our destinations. This is a list containing a navigation bar widget for each of the screens we want to appear in the nav bar. Each navigation destination contains an icon and a label. Just a heads up, if you only define a single destination and save the file, you'll get an error. The navigation bar widget requires at least two destinations. Now when I perform a hot reload, we'll see the nav bar in the simulator. The second property we need to define is the selected index. Selected index is an integer that keeps track of which navigation destination is currently active. Because destinations is a list, each list item is accessible with an integer index. Setting the selected index to 0 will select the home screen, which is the first destination. And if we set it to 2, which is the last item, then settings will become the active screen. But instead of hard-coding a value, we want this to be dynamic. So we'll define an int variable named underscore selected index and set the initial value to 0. The third and final property we need to set is onDestinationSelected. This property accepts a special function that's known as a callback. This callback is triggered whenever a destination is chosen and is responsible for switching to the selected screen. In order for this to happen, the callback needs to know which destination was selected. We can provide this information to the callback by passing an argument. Let's go ahead and set this up. This function won't return a value, so we'll use the void return type. We can name our callback whatever we like. Let's go with onItemTapped. We'll provide an integer argument named index. Regardless of the name that's chosen, this argument automatically receives the index value of the item selected in the destination list. So if home is chosen, a value of 0 is passed in. If settings is chosen, a value of 2 is passed in. Within the function, we want to set the active navigation bar option. So we'll set selected index to the value of the index argument that we passed into the function. Now when we tap a navbar item, the onItemTapped function is triggered and automatically receives the corresponding index value of the navigation destination that was selected. Inside the onItemTapped function, we set selected index to this index value. We're basically saying set the active value to the one that was just chosen. However, to actually see this in the UI, we'll need to wrap the statement in a setState method. Let's perform a reload and then give it a try. So our navigation bar is working, but the screens still aren't changing. Right now, we have a list of destinations that designates an icon and a label for each navbar option. We also have an integer that sets the selected value. So we know which icon and labels to show when a value is selected. But we don't have any way of specifying which screen to show when a value is selected. To get this working, we'll create a list of screens that corresponds to the list of navigation destinations. We need to make sure that the order of these two lists match. With this list created, we can change the value of the body from a hard-coded value to a dynamic value. We'll set the body to underscore screens and then set the index to underscore selected index. Let's perform a hot reload and give it a try. This time everything works. So we have a working nav bar, but there's just one problem. If I want to add a title to one of my navigation screens, I'd need to do that with an app bar widget. And the app bar widget is created at the scaffold level, and this sits above our 3 navigation screens. This means I can't set a separate title for each screen. To address this limitation, we'll implement the Nav Bar widget using a more flexible approach. We'll be using a technique called lifting state. This simply means our app will have widgets that aren't directly connected, but still need to share information with each other. For now, we only need to keep 2 concepts in mind. First, our app will have 3 levels. And second, we'll need to pass information between these levels. As we build this out, it will start to make more sense. We'll set up our app so that each nav screen has its own scaffold, which means that each nav screen can have its own app bar. Each of these individual scaffolds will make use of a single navigation bar widget that has been extracted into a custom widget. Also, a quick heads up, I won't go in depth for the concepts that we've already covered in the previous example. Instead, I'll be focusing more on material we haven't yet learned. Once again, we'll start out with a new Flutter project. Go ahead and clear everything out except for the import statement and the main function. Let's define a stateful widget named myApp. In the build function, we'll return a material app which contains a placeholder. We'll swap this content out shortly. Let's give it a quick restart to make sure everything looks okay. Okay, this looks good. Similar to the first tutorial in this video, we're going to create a screen for each of our nav destinations. A home screen, a search screen, and a settings screen. I'll create a screens folder and a file for each. But this time, instead of placing the scaffold widget in the build function of the MyApp class, we're going to place it in each individual nav screen. So we'll return a scaffold, and inside of the scaffold, we'll define an app bar with a title, body, and a centered text widget. This means that we'll have a separate scaffold for each of our nav screens. This also means that we can customize the app bar title, the app bar action buttons, and the scaffold background for each screen. I'll create similar screens for search and settings. In main.dart, let's swap out the placeholder with the home screen we just created. First, we'll import the 3 nav screens, and then we'll set the material app body to home screen. Let's perform a hot restart once more. Okay, this looks good. Previously, we implemented the navigation bar within a single scaffold that sat at the top of the widget tree in main.dart. However, since we now have 3 scaffolds, it's not a good idea to write the code for a navigation bar in each scaffold. This would be repetitive and will be a problem to maintain. Instead, we'll create a custom navigation bar widget that we can import and use in each nav screen. By doing this, we only have to write the code once, and future updates will only require changes in one place. We'll create a folder named widgets and create a file named customNavigationBar.dart inside of it. Let's create a stateless widget named Custom Navigation Bar. Inside of the build function, we'll return a navigation bar widget. Once again, for the parts I've covered in the previous example, I'll move a little quicker. We'll define our destinations, one for each nav screen that we created. Inside of the home screen, which is one of the 3 screens our nav bar will contain, let's add the custom navigation bar widget to the scaffold. Back in the custom navigation bar widget, we also need to define selected index to store the active nav bar selection. And we need to define the callback function that gets triggered when a selection is made. For now, I'm adding in a pair of parentheses and a pair of brackets as a placeholder. As mentioned, we'll be sharing data between the multiple levels of our app. The 2 pieces of data that we need to share are selected index and on item tapped. We'll start at the bottom level with the custom navigation bar and work our way to the top. In the custom navigation bar constructor function, we'll define selected index and on item tapped as parameters. Doing so will enable us to pass this information down from the nav screens, which are one level above. So once more, I'll switch over to home screen. In the custom navigation bar constructor function call, we'll add in the arguments for selected index and on item tapped. Right now we're seeing errors. This is because we're passing in arguments through the constructor function, but we haven't set up the custom navigation bar class to handle these values. So let's do that right now. Selected index is an integer, so that's pretty straightforward. We'll mark it as final because this is a stateless widget and it's immutable. Now, if you remember, on item tapped is actually a function and not a variable. So that's why we need the void function part. This statement basically says that on item tapped is a function that accepts an int value and does not return a value. The concept of passing a function as a value might seem a little confusing at first, but in the end, all we're doing is giving the custom navigation bar access to a function that lives outside of the class, and then running that function inside of the class. Next, we need to add selected index and on item tapped to our constructor function. The constructor function is called when we initialize a custom navigation bar. Inside the constructor function, we want to make use of selected index and on item tapped, and we refer to them by using the this keyword. We'll swap out the hard-coded values for selected index and on destination selected with the dynamic values we just created. Okay, back in the home screen, we're still seeing 2 errors in the custom navigation bar constructor function call. This is happening because the values we're passing in for selected index and on item tapped don't exist within the home screen. These values actually need to be passed into the home screen from one level above. So we're going to do something similar once more and set up our home screen class to accept values for selected index and on item tapped. This means that we'll be able to pass in data from the My App class, which is the top level of the app. Real quick, at this point, I'm going to update the search screen and settings screens with the changes we just made to home screen. Since these are almost identical screens, I'm going to copy and paste and then change the names of the classes and text widgets. Okay, we're back in the main.dart file. Now, this is where everything will come together and start to make sense. At the lowest level of our app, we have the custom navigation bar, which receives values for selected index, and the on item tapped callback from the nav screens, which sit one level above. That is, the home screen, the search screen, or the settings screen. And in turn, these nav screens also need to receive these same values from one level above, which is the top level of our app, the My App class. It's here where we'll actually define a value for selected index and declare the on item tapped function. Let's create both of these. Selected index is an integer, and that's pretty straightforward. Once again, this is simply the value of the active nav bar selection. For the on item tapped function, we're defining the exact same function as we did in our previous example. We're passing in the index of the nav screen the user has chosen and assigning it to selected index. And to update the UI, we'll wrap it in set state. However, what we're doing differently this time is that we're sending this information down multiple levels. Remember, our home screen class is expecting these two values to be passed in. So in our material app home, within the build function, we'll add both selected index and on item tapped to the home screen constructor function. We're almost done. At this point, things are looking pretty good. There's one last thing we need to do. Right now, the material app home is hard coded to the home screen, and we need to change it so that the screen is dynamic and will update whenever a new navbar destination is selected. To make this dynamic, we'll create a method called setScreen. Depending on the value of selected index, the setScreen method will set the active screen accordingly. To do this, we'll use a switch statement. If this is your first time seeing this statement, it's an alternative to an if-else statement and is better suited for situations where you have more than a couple of conditions. The switch statement consists of a switch, which accepts a variable or expression. This is followed by multiple cases that correspond to a specific value of the variable or expression. When the value passed into the switch statement matches a case, that specific block of code will execute. There's also a default case that acts as a fallback. This will run if none of the other cases match. So in our situation, we'll pass in the selected index, which represents a navigation destination or the active screen. This will be a value of 0, 1, or 2 and corresponds to home, search, or settings. And depending on the value, we want to return the specific screen that should be set in the material app home. In the material app home, we'll call the setScreen method. Now when we restart the app, everything works. When we tap on navbar destinations, we not only see the body update, we can see that each screen has an app bar with its own screen title. Okay, now that everything is set up and running, let's take one more look at how everything works. Our MyApp class, which sits in main.dart, is the entry point of the app and designates home screen as the first screen to be shown. The home screen is shown initially because we set selected index to a default value of 0, and this triggers the default case in the setScreen method. Home screen, along with the search screen and the settings screen, sit one level below and are the three destinations in our nav bar. Each of these nav screens, when initialized, will get the onItemTapped function and selected index passed to it. And each nav screen has a scaffold which contains the custom navigation bar widget, which is the final recipient of the onItemTapped and selected index values. Without a doubt, the most important concept to understand here is how onItemTapped works. Think of it this way. When onItemTapped is triggered from the custom navigation bar, we're actually running onItemTapped from within my app. And when onItemTapped is executed, we set a new value for selected index and trigger the setState method. This then triggers setScreen and once more passes this new data down the chain. This whole cycle repeats every time a new value is selected. So if this is still a bit confusing, it's perfectly understandable. This is a pretty tricky concept to understand, and you might have to go through it a couple of times in order for everything to make sense. Okay, so this video is getting a bit long, but I think it's absolutely necessary to spend a few minutes to cover Nav Bar customization. In the interest of time, we'll move quickly. The Navigation Bar widget is highly configurable. In addition to setting the icons and labels, which we've already done, we can also set colors and other properties for just about everything. We'll cover 4 properties just to get a feel for things, but overall, customizing elements of the nav bar is very intuitive. Most properties accept a color value or a number value, such as height or milliseconds. Let's start with the background color. To set a background color, we add the background color property and then set a color value. We can do the same for the active selection by setting the indicator color property. Once more, I add the property and set a color value. This time, let's adjust the height, which accepts a number value. To control whether labels are displayed, we can set the label behavior property. This property uses predefined enum values. VS Code shows us the available options for this setting. Again, in the interest of time, I didn't cover everything here, but if you'd like to learn more about the additional configuration options available, I've linked to the official documentation, which is very comprehensive and covers all of the available customizations. All right, that does it for this video. Thank you for watching, and I'll see you next time.